Hello, hi everyone. Welcome to the Student Brand. This is your Shiva sir from Student Brand. So today we are going to discuss about light reflection and refraction, CBSE Grade 10 Physics. CBSE Grade 10 Physics. Now, light reflection and refraction. Light is a form of energy which gives the sensation of sight. So, light is a form of energy which gives the sensation of sight. When light incident on the surface, it reflect back. When light incident on the surface, it reflect back. That reflected ray will reach to us, then only we can able to see the object. Then only we can able to see the object. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. The light which is incidenting on the surface is called incident ray. The light ray which is reflecting back from the surface is called reflected ray. The light ray which is perpendicular to the surface is called normal line. Is called normal line. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. So here I am considering the plane mirror. This is the plane mirror. Okay. Here this is the plane mirror. This is the incident ray, reflected ray, and this one is the normal line. Sir, why you are drawing normal line with dotted lines? Why are you drawing normal line with dotted lines, remaining lines with normal lines? Because that normal line is perpendicular to the plane surface. Actually, it does not exist. For understanding, for knowing about reflection of light, we are drawing the dotted lines that is perpendicular to the plane surface. Perpendicular to the plane surface. Okay, the line which is perpendicular to the plane surface is called normal line. The light ray which is incidenting on the surface, that is called incident ray. Incident ray, reflected ray, and the normal line. This is the normal. So one more line is there. The light ray which is deviating through the surface. So like a undeviated line. Normally, so you can see light will move in a straight line path. Light will move in a straight line path in homogeneous medium. In homogeneous medium, light ray will move in a straight line path. In a straight line path. In heterogeneous medium, light will change its direction. When it is moving from one medium to another medium. When it is moving to heterogeneous medium, light ray changes direction. But in homogeneous medium, light ray will travel in a straight line. Light ray will travel in a straight line path. So, this is the undeviated line. Light, if the normally how the light ray will move in a straight line path. There are 7 properties of there. for light, 7 property, rectilinear propagation of light, refraction, diffraction, interference, polarization, photovoltaic effect, like that. Okay, so these all properties are there. These all properties are there. Among those, one property is rectilinear propagation. Rectilinear propagation of light. That means light moves in a straight line path. Light will move in a straight line path. That too in homogeneous medium. That too in homogeneous medium. So what is homogeneous medium? Homogeneous medium means the properties of the medium, the properties of the particles present in the homogeneous medium exhibit same properties. Or if you are taking in any medium, the properties of the particles will be same. The particles properties will be same. That medium is called homogeneous medium. Heterogeneous medium means the particle exhibit different properties. That is called heterogeneous medium, right? So now here the light ray will move in a straight line path. A light ray will move in a straight line path. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between undeviated line and reflected ray is called angle of deviation. Angle of deviation. Sir, everything is okay. So I am very clear with your concepts. What are you saying? So I am very clear with your concepts. But one thing I am not getting, that is here angle of incident, angle of reflection, angle of deviation is all are there in a straight in a linear path. In a linear path. Yes or no? So what is the angle of deviation formula? What is the angle of deviation formula? Now we will discuss. That is, so for before that we will discuss laws of reflection. Laws of reflection. Those are first one, laws of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to incident ray, reflected ray, normal line. Once again, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Once again, listen carefully, very very important. Incident ray, reflected ray, normal line lies in the same plane. Once again, be very clear. Incident ray, reflected ray, normal line lies in the same plane. Point number 1. Point number 2. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. These two are laws of reflection. Once again, listen carefully. Incident ray, reflected ray, normal line lies in the same plane. Point number 1. Point number 2. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So, these two are laws of reflection. These 2 points are laws of reflection. Now, we can take angle of incidence plus angle of reflection plus Angle of deviation equal to 180 degrees. Everybody, are you listening or not? Are you listening or not? Once again, listen carefully here. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. We know that angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. By considering from laws of reflection, angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of reflection. Angle of reflection equal to, so angle of deviation if you are taking 180 minus 2 angle of reflection also we can take. Once again, listen carefully. Listen very carefully. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So these two are laws of reflection. Reflection is nothing but the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection. Right? Very good. Now we know that angle of incidence plus angle of reflection plus angle of deviation equal to 180. Linear angle is 180 degrees. So linear angle is 180 degrees. Okay. So I am taking linear angle is 180 degrees. So with that, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Now here from this, from laws of reflection, in the place of angle of reflection I am taking angle of incidence. So angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear to you all, right? Yes. So now we are moving on to the next topic, that is regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection we'll discuss now. So I'm taking this plane mirror. This is the plane mirror. Regular reflection takes place on this plane mirror. This is a smooth surface. Here what I consider, this is the smooth surface. Incident light rays are parallel to each other. 1, 2, 3, 4. Okay. Incident light rays are parallel to each other. Incident light rays are parallel to each other. Then reflector light ray also parallel to each other. Incident light rays are parallel to each other. After reflection, if reflector light rays are also parallel to each other, if reflector light rays are also parallel to each other, that type of reflection is called regular reflection. Incident light rays are parallel to each other, then reflector light rays are also parallel to each other. Reflector light rays are also parallel to each other. That reflection is called regular reflection. Regular reflection. Yes or no? Regular reflection. Okay. So incident beam is incident light rays are parallel to each other. The reflector light rays are also parallel to each other. Okay. So this type of reflection is called regular reflection. Coming to irregular reflection. Incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Incident light rays are parallel to each other, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection. So here you can see this is one light ray, this is one light ray, and this one is one light ray, and you can observe reflector light rays are not parallel to each other. Reflector light rays are not parallel to each other. Incident light rays are only parallel, but reflector light rays are not parallel to each other. Not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection takes place. Irregular reflection takes place. Irregular reflection takes place on rough surface. Rough surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Are you understanding? Are you listening? Are you listening? Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Yes or no? Yes or no? In regular reflection, incident light rays are parallel to each other. Then reflected light rays are also parallel to each other. This type of reflection is called regular reflection. So coming to irregular reflection, incident light rays are parallel, but reflected light rays are not parallel to each other. Reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. Irregular reflection. I hope it is very clear to you. Next one, I will discuss about object and image. Sir, we know that no, sir. Object and image. Why you are discussing again? But here, real object and virtual image. Real object and virtual image. Yes, sir. Right. Next one, object and image. We'll discuss object and image. Object and image. Real object. Real object. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? So I am taking 2 light rays. So we can extend those reflector light rays. We can extend those reflector light rays. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Here, their image is forming, that is called virtual image. Virtual image. The point of intersection of reflector light rays. The point of intersection of reflector light rays is called virtual image. Point of intersection of extended reflector light rays. Directly reflector light rays will meet, that is called real image. Extended reflector light rays. This one is the reflector light ray. This one is the reflector light ray. We are extending those reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming, that is a virtual image. That is a virtual image. Now you are considering here light rays are coming from infinity. Light rays are coming from infinity here. I am taking like this. After reflection, though light rays are meeting at one point. After reflection, though light rays are meeting at one point, their image is forming. That is a real image. Real image. We are extending the incident light rays. We are extending this incident light rays. Incident light rays are meeting. Okay, extended incident light rays. Extended incident light rays are meeting at one point. These are the extended incident light rays. Those are meeting at one point. Their virtual object is forming. Virtual object is forming. Once again, be very clear with that. So concept is very important. Concept is very important. Be very clear with the concept. Here from this point, light rays are coming. From this point, light rays are coming. Okay. So that is the real object. Because incident light rays are coming starting from one source. Starting from one source, that is that object is called real object. After reflection, we are extending the reflector light rays. We are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is the virtual image. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here, after reflection, light rays are meeting at one point on the principal axis. After reflection, light rays are meeting at one point on the principal axis. Their real image is forming. Their real image is forming. If you are extending the incident light rays, extended incident light rays are meeting at one point. Their virtual object is formed. Their virtual object is formed. Now you have to be very clear with these topics. That is, if the object is real, image is virtual. So I am saying very clearly to you all. So this is our Seva sir from Student brand. I am saying very clearly. Yeah, next topic, that is Swati swing. So after completion of plane mirror, I will explain about spherical mirrors, concave mirror and convex mirror. So Swati Singh, user ID Swati Singh. After explanation of plane mirror, I will discuss about spherical mirrors. Those are concave mirror and convex mirrors. So wait some time. Okay. Here I'm saying very clearly to you all. I am saying very clearly to you all. Listen here. If the light rays are coming from one point, okay, after reflection, light rays are moving away from the principal axis. If you are extending this reflector light rays, extended reflector light rays are meeting at one point. Listen carefully. Come on. Extended reflector light rays are meeting at one point. Their image is forming. That is virtual image. Light rays are coming from infinity. After reflection, light rays are meeting at one point. Their image is forming. That is a real image. So very clear. Here real image and virtual image. Here it is real image and here it is virtual image. We are extending the incident light rays. Extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their virtual object is forming. Right? Yes. So by seeing this concept, by observing these two diagrams, listen very carefully. So focus. I am your Siva sir from Student brand. I am saying, by observing these two diagrams, Object is real. If object is real, image is virtual. Object is real, image is real. Object is real, image is real. Object and image. Object is real. Object is real. Image is virtual. Object is virtual. Image is real. Yes or no? Yes. So next, moving on to the next topic. Moving on to the next topic, we are going to discuss about one more topic. Are you listening? Hello then. Now, so plane mirror, here, object, this is the object, size of the object AB. Minimum light rays are required to form the image of the object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So here, when the light ray is passing along the normal line, if the light ray is passing along the normal line, what happens? If the light ray is falling or incidenting along the normal line, the reflected ray moves in the same direction. Reflected ray moves in the same direction. In that case, angle of incidence is 0, angle of reflection is 0, and angle of deviation equal to 180 degrees. This angle is called 180 degrees. Angle between reflected ray and undeviated line. Reflected ray and undeviated line. This is very, very important. Very, very important for 1 mark. 1 mark. Very, very important. If the light ray is moving, if the light ray is passing along the normal line, it reflects back into the same path, or it retraces its original path. It moves in the same direction. Okay, so now same thing I am considering here also. The same concept I am applying in this concept. Now you can see here, one light ray I am taking along the normal line, so it reflects back, it moves in the same direction. One more light ray I am taking along this one, it reflects back, and one light ray I am considering here. As I said, if the light ray moves along the normal line, it reflects back into the same path. So it retraces its original path. So it moves in the same direction. It moves here also. It reflects back. It reflects back. Yes or no? Yes. Now, so we have to extend to get virtual image. To get virtual image, we have to extend the reflector light rays. So here is one is reflector light ray. Here also reflector light ray. Here also. We are extending these reflector light rays. So here we can observe, yes or no? Here the image will form. Hi HRS, how are you? So here the image will form here. What type of image will form? What is the nature of the image? Virtual, erect, and same size. Be very clear. Listen carefully. Very, very important one. We are extended reflector light rays. Those reflector light rays are meeting at one point. If you are joining that, their virtual image is forming. What type of image? Virtual, erect, and same size. Virtual, erect, and same size. Very nice. So what is the nature of the image formed by the plane mirror? Nature of the image formed by the plane mirror. Point number 1, object is real, image is virtual. Object is virtual, image is real. Second one, as I said to you, okay, the distance between this is the mirror, this one is the mirror. The distance between mirror to object, be very clear. The distance between mirror to object is called mirror to object is called object distance. The distance between mirror to image is called image distance. Image distance. So object distance is equal to image distance. Object distance is equal to image distance. And third one, height of the image is equal to height of the object. Height of the image equal to height of the object. And coming to the fourth one, that is it magnification of the plane mirror is +1. Sir, why are you saying magnification is +1? How can you say like that? How it is possible? How can you say like that? Because as I said, object height of the image equal to height of the object. Point number 1. Point number 2, virtual, erect, and same size. Virtual, erect, and same size. That's enough. Magnification is height of the image by height of the object. Above the principal axis. Right? So, user ID Ravi, yes, it forms. Reflection takes place on smooth surface as well as rough surface also. Reflection takes place. Okay. So, depends. Regular reflection, if the incident beam, if you are taking, I already said regular reflection and irregular reflection. Okay. So, you can go and check the video what I explained. So, in this live class only, just before this, I explained regular reflection and irregular reflection. Once you go and check. Now, it also shows lateral inversion. Fifth one, it also shows lateral inversion. Lateral inversion. Sir, what is the meaning of this statement? What is lateral inversion? Sir, can you explain? Can you explain briefly about it? Can you explain briefly about lateral inversion? Sir, I am not getting the lateral inversion. What is lateral inversion? Yes, I will explain clearly. Lateral inversion is nothing but the phenomenon of converting of right side of the object. Be very clear. Right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Once again, listen, focus. Object, right side of the object appears to be left side of the image. Left side of the object appears to be the right side of the image. This mirror image is called lateral inversion. Lateral inversion. So you can observe once the ambulance. Word ambulance written on the ambulance. Okay, it will be in the form of mirror image. If you see in the rear view mirror, it appears proper. Side view mirror of the vehicles, it appears proper. Yes or no? So that is the lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear to you all. Next one, moving on to the next topic. Spherical mirror. The mirror which is in the form of curved surface. So today I will give small introduction about spherical mirror. Later, so I will explain briefly about spherical mirrors, concave mirror and convex mirror. Those who want to know the spherical mirrors, try to check my videos, go and visit my videos. So definitely you'll get it. Definitely you'll get good concept, better concept, explanation and everything. So go and check. Today I'll just give introduction about spherical mirrors, concave mirror and convex mirror. So in the next class, definitely I'll go in depth, right? Yes. The mirror which is in the form of spherical, the mirror which in the form of curved surface, that is called spherical mirror. There are two types of spherical mirrors are there. One is concave mirror, another one is convex mirror. Concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror and convex mirror. The mirror which in the form of curved surface, as I said, that is called spherical mirror. Right? This is called spherical mirror, especially concave mirror. Based on reflection of light, spherical mirrors are divided into two types. Spherical mirrors are divided into two types, right? So here I am taking, and here also I am considering. After reflection, those light rays are moving towards the principal axis. After reflection, light rays are moving towards the principal axis. That's why this concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror, right? Whenever after reflection, if the light rays are incidenting on it, after reflection, those light rays are meeting at one point, or light rays are moving towards the principal axis. That's why this mirror is also called converging mirror. Concave mirror is also known as converging mirror. Converging mirror. And convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Okay, so after reflection, though light rays are moving away from the principal axis. Right? So this is about concave and convex mirror. convex mirror are also known as diverging mirror. Diverging mirror. Right? Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. So thank you so much everyone. Those who are attending my class, listening the class and learning from this class. Thank you so much to you all. Thank you for giving an opportunity to teach. Right? Thank you so much. If you like the content, if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student Brand. You can inform your friends, ask them to come and join to the class. So thank you so much. This is your Siva sir from Student Brand. Those who want to know more about the class, try to check once my videos and watch those videos. You can get the concept. And in the next class, anyway, in the next class, I will explain once again. Thank you so much. This is Vasavasa from Student Brand. See you soon. Thank you.